Hi students, this video will quickly cover the notes for atoms and the periodic table. As you can see, I've already got the writing here, which will help make this go a little bit quicker. So when we're talking about the makeup of an atom, we should remember that an atom is the basis of all chemistry, right? It's the simplest form of matter, and all matter is made up of atoms. So everything that you see around you is made up of atoms of different types, those types being called elements, right? An element is a unique type of atom, just like carbon or hydrogen or oxygen, right? And those different atoms are different because they have a different number of protons. So each element on the periodic table will have a different number of protons. Protons are found in the nucleus. They are positively charged, and they are relatively large compared to electrons, at least. And as I've written down there, they're the ID. They're the identifier for an element. If you change the number of protons, you have changed the element. It's like an atom's soul, right? If you change your soul, if you take away from it or add to it, you are no longer the same person. Electrons are small, negative. They're in a cloud around the nucleus, and they determine how that atom will bond. We'll learn more about that later. Neutrons are large, neutral, and they're found in the nucleus. So the nucleus is the center of an atom. It contains protons and neutrons. Really, it's just kind of the place where protons and neutrons stick to each other in the center of an atom, while the electrons kind of fly around the outside in this cloud. So I like to think of an atom, if we relate it to a human, the protons are your soul. Electrons is kind of like your money. How much money you have or are willing to give or are willing to take from somebody else determines how you interact with those people around you. And neutrons are kind of like your fingers. They're important, they're good to have, but if you lose one or if you gain one, and therefore become an isotope, it doesn't really change anything, right? You're still you. You are still hydrogen. You know, I would still be Ross, right? Periodic table, we know that each square is a different element. The atomic number tells you the number of protons, and again, just as a reminder, that's the identifier. The atomic mass is the mass of an atom. So essentially, that's just the protons and neutrons added together. Yes, electrons have mass, but their mass is 1/2000th of the mass of a proton. And seeing as a proton is already essentially no mass. Now, that's odd. Why am I saying a proton is no mass? Well, in order to weigh, right, in order to find the mass of atoms, we had to come up with a unit entirely made up for measuring atoms. Because atoms are so tiny, their mass is almost nothing. So even using micrograms or something like that, right, an atom will still not even show up using a unit of measure like a microgram, because that's how little an atom weighs. So if you then are talking about an individual proton weighs practically nothing. So we made up one AMU, atomic mass unit, to describe the mass of a proton or a neutron. An electron is a 2,000th of one AMU. So that means that it's a 2,000th of something that weighs almost nothing. So we're kind of ignoring the mass of electrons at this point. So if you have your atomic mass and you want to find out the number of neutrons, you can take the atomic mass minus the atomic number. So that's the atomic mass minus the number of protons, and that'll tell you how many neutrons are normally found in that atom, as long as it's not an isotope. And remember, one AMU is one proton or neutron. It's an atomic mass unit. The atomic symbol is the letter that represents the name. The first letter is always capitalized, the second letter is not. Magnesium, Mg, will never be capital M, capital G. If it was capital M, capital G, that would be telling you that there are actually two atoms. Whatever M would be, and G is actually gallium. So if what you meant was magnesium with gallium, it would be Mg, capital G, right? That tells you that there's 1, 2. When we're writing formulas, we write formulas, chemical formulas, to describe chemical reactions, something that we're going to learn about a lot more later. So for instance, sodium plus chloride undergo a chemical reaction to create sodium chloride, salt. That line right here represents the chemical reaction. This is not the same as mixing. That's why mixing is crossed out. If you add salt to water, there's no chemical reaction that bonds salt and water together. You just have salty water. If you boil off the water, you're left with a bunch of salt. That's how you know that they did not chemically bond together. Talking about the periodic table, we did that organizational activity a little while ago, and we know that the table is ordered, first of all, by atomic number. The rows are set up by atomic number, so the number of protons from left to right. Then, the columns, also known as families, are organized by the number of electrons lost or gained, which tells you how it interacts and bonds with other atoms. So each of these columns share properties, meaning how many electrons are lost or gained. Each of these columns is going to be numbered. This would be 1, this would be 2, 3, 4, 5, 6, right? And it would be numbered so that you know that any atom in that column is going to follow the same set of rules in terms of bonding. And it's going to follow that same set of rules in terms of bonding because of the number of electrons lost or gained. Noble gases, all the way over here, do not lose or gain any electrons. It means that they don't bond, because the outer layer of their electron cloud, also known as their valence electrons. Valence electrons is the same thing as the outer layer, is totally full. So they can't accept any more electrons. And also, since it's full, they don't want to give away any electrons. It's like if you wanted to have $10 to buy some new toy, and you don't need any more money than that $10, so you're not going to take anybody else's money. You're also not going to give away any of your money, because if you do, now you can't buy that toy. So noble gases are kind of like you holding onto that money so that you can go to the store and buy whatever you wanted to buy. You're not going to give any away, you're not going to take any, so therefore you're not going to interact with anybody. You're going to go straight to the store. And those noble gases kind of do the same thing, except they're not shopping. So this right here, this box, is just an image showing you what you would see in the periodic table. 19 up here is the atomic number, that's the number of protons, and down here is the atomic mass. So if I wanted to find out the number of neutrons, I would take the mass, 39.10, subtract 19, and I'm left with 20.10. This 0.10, we're going to ignore that, because that is the mass of the electrons. 20, therefore, is what is left over to be the mass of the neutrons, which means that you have 20 neutrons. Here's just a quick summary of atoms. We're looking at mass, charge, and location. Electrons essentially have no mass, a negative charge, and are found in a cloud. Protons have a mass of 1 AMU, positively charged in the nucleus, and neutrons are 1 AMU. They are neutral, so you could either put a equal sign, or I just kind of put a circle with a cross through it, showing that there is no charge, and the location, again, is found in the nucleus. I'll make another video to talk about bonding in a little while, but for now, this should get you started with your understanding of atoms, their structure, as well as the organization of the periodic table.